Now that's basically the foundation, the start. Okay, now let's do some problem right away. I pick questions from the book. Let's say, for example, we do number 2 first. Number 2, I hope you have your textbook with you, page 405. Okay. Number 2, at the start of an experiment, so at time 0, the amount is, or in this case the n, is 2 times 10 to the 4 bacteria. Now, if you want to make it more relevant right now, then call it viruses. Okay, 2 times 10 to the 4 viruses are present in a colony. And then 8 hours later, t equals to 8. Notation-wise, that will be an 8. The population of the bacteria is 3 times 10 to the 4th. Okay, now the question then, find the equation. Okay, for us to find the equation, then we need to know the initial amount, which we already have. Okay, and then the coefficient of growth, which we don't have yet. Now, then how do we do this? Well, anyway, from the first one there, we know that nt will be equals to 2 times 10 to the 4th e to the kt. Are you with me? That's our n0, the initial amount. Okay, and then using the second number, n8 equals to 2 times 10 to the 4th e to the 8k. Now, at the same time, we know that the number of bacteria at time 8, at the 8th hour is 3 times 10 to the 4th. Now, what we will do next, we will solve for that k. I divide by 10 to the 4th cancel, so I have 3 over 2 equals to e to the 8k. Now change this into logarithmic form. Natural log of 3 over 2 equals to 8k. So k equals to 1/8 of natural log of 3/2. Okay. Now, don't round it, okay? That's write it in exact form, and then you use the approximate form, okay? So, natural log of 1.5, whatever the result, divided by 8, I get 0.05068, okay? But when it comes to, if we need to use this k in future computation, we need to use this. Use exact form in subsequent computation. That way we can avoid rounding error. Okay, that way we can avoid rounding error. That's the k. Therefore, now we have the full formula, nt equals to 2 times 10 to the 4th, okay, e to the kt, where the k is 1/8 natural log of 3/2. Okay, you can just write it that way. You can just write it that way. Now, let's see. How about part B? This is my part A. Well, the part A is actually just to find the k though. Now, part B, what was the population 2 hours after the start of the experiment? So basically, what is N2? And I will use this formula here. I will use this formula here. There. So 2 times 10 to the 4th times e to the 2k, where the k is 1/8 ln 3/2. So that's, you know what? Now I know why. Okay, so that's 2 times 10 to the 4th e to the 1/4 ln 3/2. Okay, and from there you can use calculator, even though if I were you, I would do a bit more simplification. Notice that I can write e to the ln 3/2 to the power of 1/4. It's e to the ln 3/2 to the power of 1/4. Now the reason is then we can simplify that to be, that's 1.5. This guy becomes 1.5. That's 1.5, okay, to the power of 1/4. So basically the 4th root of that, okay? Anyway, 2 times 10 to the 4 times 1.5 to the 1/4. I get 22,133.63839. Okay, now because it has something to do with the number of bacteria, then you may want to do rounding. Okay, but when we do rounding according to the regular sense. Now the third one, part C, find the time, how long will it take for the population to triple? The t be the time to triple. Now the time to triple is also known as tripling time. The time it takes to triple the initial amount. Okay. Now we have this formula, and t equals to n sub 0 times e to the kt, where the k is 1/8 ln 1.5. Okay, now when we want to triple the amount, basically this guy now becomes 3 times n0. Divided by n0, I basically have 3 equals to e to the kt. So notice that the triple time later on, basically e to the kt becomes 3. Doubling time, that's the more well-known terminology. Doubling time is when 2 equals to e to the kt. Now then we change this into log form. Natural log of 3 equals to kt. T equals to natural log of 3 over the k, which we know to be 1/8 natural log of 1.5, or 8 times natural log of 3 over natural log of 1.5. See, I don't do rounding. I try my best not to do any rounding. I get t equals to 21.67609 hours, because the unit is hours. Okay, so if you wait approximately 21 hours and 60 minutes and 40 minutes, 21 hours, right? This is approximately 2/3, right? 21 hours and 40 minutes, then the number of bacteria will be triple the original amount, which will be 6 times 10 to the 4, 60,000 bacteria. Okay. Now that's for question number 2. Now you will see other questions are actually very similar to this number 2. Let's see, for example, we go to number 8. I don't want to spend too much time here though. Okay, so I do one more question for exponential growth, and then later on we do exponential decay. Okay, number 8. In year 2000, the nation of Mali and Cuba has similar size. Mali in year 2000, Mali has 11.2 million, and Cuba has 11.2 million. I'm sorry, 11.1 million. Okay, however, the relative growth rate for Mali, so the K, is 3.1% per year, while for Cuba is a lot slower, that's 0.7% per year. Okay, assuming exponential growth at the different rates, make projection for each population in year 2015. So part A, year 2015 implies T equals to what?
15 years.
That's right, it will be 15 years. Okay, now for Mali, the growth, let me use an M for Mali here, T equals to 11.2 times e to the 0.031 T, while the growth equation for Cuba will be 11.1 times e to the 0.007 T. Okay. Now then, so part A, we can answer them already, right? We just plug in the formula. So for Mali, in 15 years, the growth will be 11.2 times e to the 0.031 times 15. While for Cuba, it will be 11.1 times e to the 0.007 times 15 on the exponent. Okay, you can compute this yourself. Now part B. Part B. When might the population of Mali reach 20 million? Find T such that N at Mali T equals to 20 million. Then 20 equals to 11.2 times e to the 0.031 T. We need to solve this equation. Okay. Fast forward, you will see T equals to natural log of 20 over 11.2 divided by 0.031. Okay, then you use your calculator. Okay, now then the same question for part B. What would the population of Cuba at that time? Now, once you find that T, you plug that T into Cuba one. So whatever the T you have here, that's the T you will use there. Okay, that will be equals to 11.1 times e to the 0.007, whatever that T be. That's for part B. Next one. Number 28. Number 28. The radioactive isotope carbon-14 is used as a tracer in medical and biological research. Compute the half-time of carbon-14 given that the decay constant is this number. Okay, so they tell us the K, which is negative 1.2097 times 10 to the negative 4. And the question is compute half time. So find the T such that n of that T equals to half of the original amount. Okay. Now, but we also know that NT, the formula for NT is the original amount times e to the kt. Okay, so divide by the n sub 0, the n naught, we get 1/2 equals to e to the kt, the natural log of 1/2 equals to kt. Therefore, t equals to natural log of 1/2 over k. That's half time. I'm sorry. Yeah, that's right. That's half time. Find the half time. Notice that when we want triple time, if you look up here, when we did triple time, it will be ln 3 over k. Half time, it will be ln 1/2 over k. Okay, so doubling time will be ln 2 over k. Okay, half time will be ln 1/2 over k. So going back, then this will be ln 1/2 over, what is the k? Negative 1.2097 times 10 to the negative 4. We can say ln 1/2 is negative ln 2, by the way. Times 10 to the positive 4. So ln 2 divided by 1.2097, the negative cancels, okay, times 10 to the 4, that will be, the t is...
Sorry, why is the natural log of 1/2 natural log of 2?
No, it's negative natural log of 2.
Oh, how'd you get that?
Well, because 1/2 is 2 to the negative 1.
Oh, okay.
Okay, so the half time is 5,000 something years. Okay, that's for number 28. Now, using that formula, suppose I use that formula to number 32. Number 32. Number 32, half time of radium-226 is 1,620 years. T of half time is 1,620 years. Now the question is, how much of 2 gram samples remain after 1,000 years? Well, the first thing you need to do is to find the K. Once you get the K, you get the equation. It's 2 times E, maybe I use the formula. And 0 e to the kt. Okay, and then after you know that, then we need to find N100. You see what I mean? But first I need to find my K. Okay, once I get the K, then I get the formula. Once I get the formula, then I can use that formula to find how much of the radium left after 100 years. Okay, then what is the formula for K? Well, half-time formula. Half-time formula equals to natural log of 1/2 over K. Remember that? This is our plan. Now, the thing is, the T is known to be 1620, negative ln2 over K. So K equals to negative natural log of 2 over 1620. In decimal, that will be a very small number, I expect. That is 4.27869 times 10 to the negative 4. Okay, I use 5 decimal places here, but to be more precise, this is 5 significant digits. I think I should say 6 significant digits. Okay, now that's the K. But even though I have that approximate K, I will use the exact one in my future computation. Okay, now once I get that K, then my NT equals to, you start from 2 gram sample, right? 2 times e to the kt, where the K is negative ln2 over 1620. Now what happens if you wait until for 100 years? Then it will be E 2 times E to 100 K. Okay. Now I already have that K in decimal on my calculator, multiplied by 100. Okay, now 2 times e to the answer. Now you try to compute it yourself, please. Try to compute that yourself. ln2 divided by 1620. I need to take the opposite of that. And then e to the power multiplied by 2. Oh, so after 100 years, I get 1.99914 grams. It reduced by very little bit only.
Oh, is that I got a different number. That's because you used you didn't use the decimal form of the K.
You can, but the thing is, even though the number seems to be very small,
Mm-hmm.
okay, but once you do rounding, when it comes to exponential functions,
Mm-hmm.
okay, once you do rounding, the error may be very big. What do you get, by the way?
I got 2.08.
Oh, no, it won't be. That one must be because you forget to put negative in
Oh,
your exponent.
oh, yep.
Yeah, notice the reason I know right away that it's not, and I know that that must be your mistake, is because this is radioactive decay.
Yeah, yeah.
So over time, the amount must be less than 2 grams, not more,
Oh, okay.
right? Mm-hmm. So it must be because you missed the negative sign.
Thank you.
Mm-hmm. Now part B, find the time required for 80% to decay. So part B, 80% decay means what percent left? 20%, right? Okay, so basically it means 0.2 of the initial amount. Now we set that remaining 0.2 of the initial amount equals to initial amount times e to the kt. So 0.2 equals to e to the kt, right? So the t will be natural log of 0.2 over k equals to t. Now then we use our calculator. T is,
What if we just take 80% of 2 and then set the equation? The
80% of 2. Oh,
80
no, not 80% of 2. It should be 20% of 2.
should be 20% of it?
Yeah, because 80% decay,
Oh,
right? So find the time required for 80% to decay, which means only 20% left,
oh,
right?
I would have to say, okay, yeah, I see what you're saying.
Uh-huh. Uh-huh. So T will be, what's our K? Now we have our K earlier. Let me see. This is ln2 minus ln10 over, what's my K? Negative ln2 times 1620. So that would be negative 1 plus log base 2 of 10 times 1620. Now don't worry about me. Don't worry about this though. Don't do this because I end up doing it in a way that you cannot use calculator. You can just use this thing. You can just use this thing. Erase this guy here. We don't like that. This is ln 0.2. Okay. So ln 0.2 divided by ln2 multiplied by 1620. That will be 3761.52351 years. Okay, that's for number 32B, suggested homework from here. I don't need you to do a lot, but I need you to have basic understanding on how to set up the equation, find the half time, so on and so forth. 5.7, suggested homework will be, number 1 should be easy. Number 3 should be easy. Number 7. Number 11, I think that's enough for the growth. How about for decay? The decay, number 25, 27, 29, 31, I think should be good enough. Okay. By the way, a bit more about decaying. Uh, when we take a medicine, let's say some drug, okay, let's say marijuana. Let's say we take some marijuana. Okay. This is a big example. This is a very, very big example. Now, notice that the amount of that marijuana in our blood, okay, will also decay exponentially. So suppose we take some ecstasy, okay, somebody crazy enough and take 100 milligrams of some crazy drug, okay, and then we have an equation that the amount of drug in our body will decay every, let's say, 6 hours. Okay, the half time is 6 hours. So let me say T half equals to 6 hours. In fact, for marijuana, it's actually, no, it stays in your blood, it stays in your body quite long time. Okay, but let's say this is just an example. Okay, so if the half time is 6 hours, then what is the K? Now, the reason I want to find the K is because I want to find the formula in general. You see what I see or what I say? Okay, now then we know that half time formula is natural log of 1/2 over K. Therefore, K is equals to natural log of 1/2 over, in this case, 6. Okay. So my K is negative 0.1155245 I make it long. Now, so the amount of that drug in my body will be 100 times e to the kt, where the K is natural log of 0.5 over 6. Now, you know this drug will be decaying, right? Now, imagine if you drink some beer, you have some alcohol, okay? Now, how do they know that you actually drive under influence if you have some alcohol? Then they give you some breathalyzer, for example, right? Okay, now breathalyzer will be able to detect some alcohol in your blood or in your breath, to be more precise, if the concentration or the amount of alcohol in your blood is still high enough to be detected. Okay, now, and you see the amount of alcohol in your breath or in your blood will decrease along the time. But suppose you drink only 1 hour earlier, then how much drug you think will be in your blood if I use this example? Okay, so suppose then somebody, let's say Thomas is so crazy, he gets some ecstasy, okay, get some crack, and then somebody don't like him, go to his house 3 hours later, and they need the blood check. Okay, then how much drug in his blood after 3 hours? That's basically this situation. You see what I mean?
Yeah.
Right? Okay, now which when I compute, what's that? Times 3, okay, and then e to that answer multiplied by, I'm sorry, not sure. then they will find that's equals to 70.71068 milligrams. Okay. Now, here's the thing though. Here's the thing. I tell you this based on my own experience and not to not to politicize anything, but when I first came to the United States, I went to Marine Corps, and one of the things they asked me question at that time is, did you use marijuana in the past? And I never used marijuana. Okay, I never used marijuana. So I say no. Okay, well, regardless what you say, they test you anyway, right? Now, the thing is, the drill instructor said this: if you took any amount of marijuana in the last 2 years, we will be able to detect that. And that's kind of like surprised me so much, because if they can detect that even after 2 years, it means the test they have is very, very sensitive. You see what I mean? Okay. Now suppose we use this number here just out of curiosity. Okay, just out of curiosity. Okay. Now I changed the storyline a little bit. Let's say I change this into 6 instead of 6 hours. Let me make it 6 days. Okay. Let me make it say that in 6 days. So the amount of that, whatever that drug, let's call that marijuana, will stay in my body, have half time of 6 days. Now then, so 2 years will be what? How many 6 days in 2 years? 366, let's say, multiplied by 2, divided by 6. There are 122 6 days, right? Then there will be 10 times e to the 122 times k. Now my k again is natural log of 0.5 divided by 6 multiplied by 122. So this is the number I have right now, 100 times e to the negative 14.09399. I get 7.5692 times 10 to the negative 5. 0.000075693 milligrams. It's so sensitive that even if the amount in your blood is so small, they still can detect it. Now, one thing you know about exponential form, one thing you know with exponential form, notice that this k is negative in this case, right? So the graph will be, if we sketch the graph, it will be decreasing graph. Are you with me?
Yes.
Okay. Now notice that the asymptote is 0. In other words, however far you go in time, the value will always be positive, right? It may be very close to 0, but will never be 0.
So you're saying it'll stay in your system forever or something?
Yes, that's what I'm saying. So once you take that kind of drug, it will stay in your body forever. Of course, the amount will be less and less. Okay. Now, because the amount is less and less, then at some point, let's say the amount of that drug in your body, the concentration is so low that no test can detect it, right? But it's simply because the test is not sensitive enough. You see what I mean? Okay, but it's just about time they can find they can invent a new test that is sensitive enough to detect them. Okay, now let's see the current situation with our COVID. Again, please don't take anything what I say here in political point of view. No, 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 no. I want to see the challenge that we in science actually encounter. Okay, first big question. First big question. Why the test is expensive if we need it fast? Okay, the test we have can test only one person. But that test itself takes approximately 5 hours to process. Okay, the cost of this test, I was told, the last one I heard is around $600 per test. That's not including the nurse who do that for you, not including the machine they need to buy to process your chemical, your DNA, your saliva. Okay, now so plus this plus that, it ends up, let's say, to be 1,000. Okay, now the nice thing about this is this test is actually quite sensitive. This test is actually quite sensitive. So how to make it cheaper for us? They make it cheaper by pooling, instead of only one patient, they pool 20 patients. So the saliva from, let's say, the whole class being put together. Okay, they put together and they do the test one time. They know their test is actually quite sensitive, such that when they pull 20 people and test it together, of course, it costs a total of $1,000 to test it one time. Okay, but at least you see when they test it, $1,000 divided by 20 people, that's $50 per person. Do you notice that?
Mm-hmm.
Right? Okay, so it's a lot cheaper if they wait and have more people to test at once, right? After all, their test is quite sensitive, such that even if you have small amount in your body, they can find it. Okay, now, so what happens if all these 20 people are actually clean? They test it one time, the result is clean. The result is negative. Then only testing one time, 20 people done. You see what I mean? No? Because the test is quite sensitive, they can just run the test one time and clear 20 people at once.
Yeah.
Okay? The problem is what happened if they find it to be positive. Suppose the result is positive. Now then, if the result is positive, if positive, then at least one has COVID, right? So what they do then, they do the test again, but this time they make it 10-10. Is it okay? Yeah. And they hope so much that one of them clean. If one of them clean, if one of them negative, it means all 10 people from here is clean. You see what I mean?
Yeah.
Okay. It means the positive one is here, right? If they do the first 10 is clean, then you can release these 10 people. The other 10 people, they don't test that. Okay, they know when they test this, it will be positive. So what they do is they break it up into two, 5 and 5. 5 people and 5 people. Okay, suppose the first 5 is tested positive. Okay, now if it's tested positive, then there must be something wrong here. Then they break it up further. You see, let's say 3 people and 2 people. Of course, they still need to test this one though. It is possible you have some people positive here and some people there, right? But they keep on breaking it up, let's say 3 and 2. And then, of course, some of them expect it to be clean. If some of them to be clean, you can use this one test to get rid of, to release 2 people at once, right? But notice that using this technique and relying on the sensitivity of the test, instead of doing the test 20 times, 1 test per person, okay, 1 test per person. Imagine if they need to do it one test per person. For 20 people, it will cost 20,000, right? Now, if they do it this way, the number of tests, even if all of them, if all of them actually have the, is tested positive, of course it will cost more, but the chance is actually quite small. Okay, the chance is that if they do this way and then approximately only half of them actually tested positive, then the number of tests they need to do is actually much, much less. And they still save money. You see, because imagine if I can do 1 test and it happens that everybody in that pool is clean, then you can release 10 people by just losing another 1 test instead of 10 tests. You see what I mean?
Yeah.
Okay, now that's why that one of the things we try to do, not only for this COVID, for any testing, if we want to test if this person have the certain type of virus, okay, and that test happen to be expensive, then that's why they say, you know what, you need to wait 1 week. Okay, does it mean that you need to really wait 1 week for the result to come out? Actually, not really. They say wait 1 week because they want to wait for other people doing the same test. Okay, so if you want to check, for example, if you have this certain virus, right? Okay, after all, they know a lot of people needs to do this COVID test anyway, right? And telling you to quarantine yourself, okay, stay at home for another 1 day will not hurt you, right? So they will say, well, you know what, come back tomorrow. Even though if they do the test, it will take only 5 hours. But they tell you 24 hours because in the next 19 hours, there must be so many people need to do the same test anyway. You see the technique, right? Okay, that's how we try to say. Now, of course, you should not tell them, you know what, I need it now, I need it now, and I need it here. Okay, then they will tell you to pay a lot. Why? Well, because if you use the test only for yourself, it costs $1,000, and then you complain. Right? Why it costs so much? Well, because you want to use the test yourself. Right? Okay. Yeah. They have a test that is quite sensitive. Therefore, they can test more people at once. Okay. Another thing that people in science try to do is trying to find a test. It doesn't have to be cheaper, but another way to get around is actually more sensitive. Because the more sensitive your test, then the more people you can test at once. Does it make sense? And that way you can make it cheaper per person. Okay, now that's for this 5.7. I think I gave you the suggested homework already up there. Yeah, here, that's the suggested homework. Now let's go to chapter 6. So chapter 6 is on trig functions on acute angles. I prefer to say trigonometric functions using right triangle approach. So suppose I have a triangle, a right triangle, let's say the vertices are vertex A, B, C, and right angle at angle C. Now, the convention for the name, the way we name the side, the way we name a side is the lowercase of the angle opposite to it. So this side here is opposite of angle A. So we name this lowercase a. This side here is opposite of angle B. So we name this side B. Now, likewise, because this side here is opposite of angle C, we call that C, lowercase c. Now, sine of A is defined to be the opposite of side A, the opposite of angle A over the hypotenuse. Cosine A is the adjacent over the hypotenuse. Tangent A is opposite over adjacent. Okay, and then the reciprocal of cosine is secant. So secant A is the reciprocal. That's C over B. Cosecant is the reciprocal of sine. That will be C over A, while cotangent is the reciprocal of tangent. Okay, now because the prerequisite for this class is trigonometry, I have to assume that you already learned this before. I just need to review a little bit. Okay, now let's do one example. Suppose, for example, I have a right triangle let's say this is X, Y, Z, and this is right angle at C. Suppose I have 12 here and 5 here. I would like you to find sine Y, cosine Y, and tangent Y. Once you're done with that, then give me secant Y, cosecant Y, and cotangent Y. Okay, you need to first use Pythagorean theorem to get the other side here, the hypotenuse. Okay, let me give you 1 minute. The hypotenuse is 13. Okay, actually, before I go too far, I would like you to memorize these triplets. Very likely you already memorized it. It even has a name for this called Pythagorean triplets. Pythagorean triplets are 3, 4, 5, 5, 12, 13, 7, 24, 25, and then 8, 15, 17. There are infinitely many Pythagorean triplets, okay? But these 4 are the one show up quite often, and 3, 4, 5 is the most often. The second most often is 5, 12, 13. The third most often is 7, 24, 25. Now, the reason why I categorize Pythagorean triplets and would like you to memorize it because the product of Pythagorean triplets is also a triplet. The product, I think I say it wrong, not the product, the multiple. A multiple of a triplet, a multiple of Pythagorean triplets is also a triplet. Okay, suppose for example, let me use another color, 6, 8, 10. It must be a triplet. Why? Because this is 2 times 3, 4, 5. Okay, another one is suppose 0.28, 0.96, and 1. That's also a triplet because this is 0.04 of 7, 24, and 25. Okay. If you multiply by 2, divide by 2, multiply by any number to that triplet, it must be a triplet also. Even though you have to keep in mind the largest number of that triplet has to be the hypotenuse. Okay, the largest number of that triplet has to be the hypotenuse. Now, go back to that question then sine y will be?
Five over 13.
No.
No. Oh, 12 over 13.
Yeah, 12 over 13 because opposite of y is 12, right?
Yeah.
12 over 13, this is 5 over 13, this is 12 over 5, this is 13 over 5, this is 13 over 12, this is 5 over 12. Okay. I believe you have known that one. Now, next skill is calculator skill. Let me ask you to grab your calculator. I would like you to learn to compute the following: sine 40 degrees, cosine 70 degrees, and how about tangent 29.3 degrees. Use your calculator. Now, but before you actually start the computation, I would like you to first check the mode of your calculator. I assume you use TI-30 or TI-36. None of you supposed to use TI-83 or 84, but if you do, I don't care. Now, suppose you want to compute, what's that? What's the first one? Sine 40. On my computer, I have the emulator for TI-84. Okay, now, and then I want to compute sine 40. Now, first, you need to check one thing. You need to make sure that you are working on the degree mode. So you press the mode on your calculator. Press the mode on your calculator. Now you see here, you see my pointer? You see my pointer? Okay, my mode is still in radian. So I need to change that to degree. Okay, now very likely on your calculator you have the degree mode. If it is already degree mode, it's fine. But sine 40 will be typed sine 40, enter. Oops, sorry. I have extra zero there. Sine 40, enter. Wait, I think sine 400 will give me the same number in this case. Don't you think so? Do you know why?
3/6.
Yeah, because it's coterminal. 400 degrees is coterminal with 40 degrees, right? 40 degrees plus 360 is 400. But it's just for this number though. It just happened to be for this number. Yeah, it just happened for this number. So sine 40 degrees is 0.64279. Let me write it down first. You write it down first. That's 0.6427. And then what is the next one? Cosine 70. Cosine 70. cosine 70 equals to 0.34202. Cosine 70 degrees is 0.34202. 34202. How about tangent 29.3 degrees? Can anybody help me? What do you get?
1.64901.
1 point.
Tangent of 29.3?
Yeah, tangent 29.3. It should not be more than 1.
Oh, you know what? I think I didn't change it.
Ah,
Sorry.
what did you do with my sine 40 degrees and 670 degrees? Huh?
It's a 0.56117.
Okay, don't forget to use the leading zero, okay? 0.5
6117.
117. Let's check. That's right. Now then, the issue is what happens if we have secant, for example, secant of 63 degrees. Now, you don't have this on your calculator. You don't have this on your calculator, but you have the reciprocal cosine, right? So what you will do is you type cosine 60 degree first, and then do the reciprocal. You can type the following: 1 divided by cosine 63 degrees. If you want, that's one way to do it, even though I personally prefer to do it in 3 steps. I compute cosine 63 degrees first. Okay. Now, once you get the result, and you take it to the power of -1. You do the power of -1. Okay, let me show you on my calculator. Secant 63 degrees is the reciprocal of cosine 63 degrees. So I compute cosine 63 degrees first. Okay, are you with me so far?
Yeah.
Now, to do the reciprocal, you press this one here. Do you see that? X to the -1. Okay, now I assume you use TI-30. Okay, so your calculator will be different from the one I have here, but you must have X to the -1. Try to find out. Do you see that? On your TI-30 or TI-36? Whom of you use TI-30? Nobody say anything. I don't even know if you have calculator there. Enlarge one of the... If you use TI-30 X2S, then X to the -1 will be, the reciprocal will be right above 7. Right above number 7. Then you see X to the -1 there. Well, you find out. You find out. Okay? You find out. I don't do everything for you. Okay? Now then, I will press X to the -1 and then enter. 2.20269. And that will be 2.20269.
Response to the coronavirus saying that he made this deal with that they made a deal with Honeywell to purchase.
Hello. Are you okay with this number?
Mhm.
Okay, now your turn. How about cotangent of 37 degrees? You do it.
1.32704.
1.32704. Good. 1.32704. Okay, but you know what? When you do in your test, I need you to still write it this way. I need you to write it this way. 1 over tangent 37 degrees, then 1.20, what? 1.32. 1.32704.
Yes.
Okay, now that's the calculator one. Now to close this section, there are some special angles. You need to memorize the value. And instead of just telling you to memorize, I want to derive them. Special angles. The first one is 45-degree case. Now, the way we derive special angles, 45-degree, comes from a square. Maybe I'll make it larger. Comes from a square that I bisect diagonally. Okay. Now we know a square have 90 degrees angles. Therefore, when we bisect that, this angle becomes 45 degrees. Of course, this guy is 45 degrees also. Now, if I pull that triangle out, then you will see that we have what we call isosceles right triangle. Isosceles because these two sides are congruent, okay? Right triangle because we have one right angle in there. Now, I need you to memorize the ratio. Suppose this is 1 and this is 1. By Pythagorean theorem, this will be square root of 2. I think that's an easy Pythagorean theorem, okay? Basically, if this is 1, that's radical 2. In other words, if this were x, what will this be?
1.
Huh?
X.
Also x. How about this one?
Oh. Root 2x.
X square root of 2. Okay, so the ratio will be the same. Now from there, then we see that sine of 45 degrees is 1 over square root of 2, which simplifies to be radical 2 over 2. Cosine 45 degrees, the same. And tangent 45 degrees is 1 over 1, which is 1. Okay, I need you to memorize this though. Okay. You have memorized that before. You took trigonometry class, you should have memorized that at that time. If your teacher told you you don't need to memorize, then you have to memorize it now. Okay, I wonder how can you pass trigonometry without knowing this value. Okay, you may forget, but you have done it before. So it should be easy for you to memorize that again. Okay, that's for 45 degrees. Now, how about 30 degrees? 30 degrees, the way we develop or find 30 degrees ratio coming from equilateral triangle. Equilateral triangle means all the sides are congruent. And therefore, each angle is 60 degrees. Okay? Now, what we do next is we will bisect one of the angle. Okay, I will bisect one of the angle. But once I bisect one of the angle, the consequence will be that this will be a right angle. Okay. Now, suppose the length here is 1. What is the length here? Yeah.
Two. I'm sorry. Two.
2. Why? Because if this is 1, then this is 2. Right? But if this is 2, this must be 2 also because these 2 are congruent. Right? Okay. Now, let me not writing too much. Let me just say this is 2. And by Pythagorean theorem, this will be square root of 3. Okay. Let me get the triangle out. So the ratio is this is 1 square root of 3, 2. If I have 60 degrees here, 30 degrees here. Now from here you can find, actually you can do it yourself, what is the value of sine 30 degrees, cosine 30 degrees, and tangent 30 degrees. And then also sine 60 degrees, cosine 60 degrees, and tangent 60 degrees. Okay, let me ask you to do this, and then together with your break, we come back at 6 o'clock. Maybe 6:05. Yeah, let's come back at 6:05. Okay, let's start again. I think you should get these numbers. Okay, now let me ask you to memorize these special values. The one that you need to memorize, which I expect you to already memorize. The trig values for 45 degrees, the trig values for 30 degrees, the trig values for 60 degrees. Okay, memorize that. Even though I know you can use calculator, okay. However, when it comes to these special angles, I need you to give me the exact value. For special angles, 30 degrees, 45 degrees, 60 degrees, I want you to give me the exact value. In other words, for example, if I ask you what is sine 29 degrees, you will use calculator. Sine 29 degrees is 0.48481. But when I ask you cosine 60 degrees, you give me 1/2. When I ask you how about tangent 60 degrees, you give me radical 3. Okay? You give me radical 3 and not tangent 60 degrees from calculator, which is 1.73205. Okay, because we already developed the exact value for these special angles. Now your suggested homework for 6.1, will be suggested homework 6.1 will be number 1 up to number 23. Okay, now even though it seems like, oh, you just do the odd numbers, right? You just do the odd numbers. There are 12 questions there, even though with ABC, but each one of them should be short. Now, The later part of this section, I will not do because we will learn that anyway in future. I will skip 6.2 for now. I will do that later. Okay. We'll come back to that later. Let's do I will skip 6.2 for now. Let's do 6.3 first. 6.3, that's the direct consequence of what we learned earlier, is the application of a right triangle approach. Okay, for example, example 1, let triangle ABC be a right triangle, right angle at C. So this is C, let's say this is A and this is B. Now suppose A be 35 degrees, okay, and then AC is 100 feet. The question is, let's say, find BC. And then find AB. So part A. Now put the, if you have this kind of information here, put the numbers in your graph. Sketch that first and then put the numbers. Let's say we have 35 degrees here, and then AC is 100 feet. Okay, now part A, what's BC? Then ask yourself what relates 35 degrees, 100 feet, and BC. What trig function relates these three?
Tangent.
Tangent. So we write the equation. Tangent A equals to BC over AC. Write it that way first, and then we plug in numbers. Okay. Tangent 35 degrees equals to BC over 100. Therefore, BC is equal to 100 times tangent 35 degrees. Then you use your calculator. Okay, don't use your calculator too early. Okay, keep this in mind. Get the answer in exact form first whenever possible, and then use the approximate form. Now, what we have here is the exact form. Tangent 35 degrees multiplied by 100 give me 70 point something. That is 70.02075 feet. Okay. Once you're done with that, if you want, you can call that BC as your X, you know, and then your AB as your Y. You can also do it that way. Okay, so let me ask you to do part B. What relates 35 degrees, 100 feet, and AB?
Cosine.
Cosine, that's right. Okay, cosine. Now somebody may say, Thomas, can I use secant? Because secant actually relates those three things also. The answer is no. Don't use secant. Can you? Yes, you can do. You can use anything actually. There are so many ways to do it. But the reason we don't use secant 35 degrees because our calculator doesn't have secant. Okay, so can you do that? Yes, you can. Should you do that? No. Okay, so cosine A, cosine A is equal to AC over AB. Cosine 35 degrees is 100 over AB. So AB cosine 35 degrees is 100. Now then AB equals to 100 over cosine 35 degrees. Now use your calculator.
Um, 122.
122.
0.07745.
122.07745 feet. Okay, that's one. And the rest of this section basically application of those ideas. Further application of those ideas. For example, if I go on further, example 2, let me pick question from number 8. Number 8, from a point level with and 100 feet away from the base of the Washington Monument. So let's say I have Washington Monument somewhere. What does Washington Monument look like? Let's say it looks like this. I don't know. Okay, let's call that Washington Monument. Okay, and then from a point level to the base, 1,000 feet away. So this is 1,000 feet away. Okay. The angle of elevation to the top of the monument is 29.5 degrees. So angle of elevation from the base to the top of that monument is 29.5 degrees. Sorry, 29.05 degrees. Now the question is, determine the height of the monument. We want to find the height of the monument. What is the height here? Okay, now then you see, oh, you know what? We need to try to find a right triangle, okay? Because our approach is right triangle approach here. Okay, we have a right triangle here. That's right. Then what relates these three things is tangent. So tangent 29.05 degrees equals to h over 1,000. So h equals to 1,000 times tangent 29.05 degrees. Then from there, you use your calculator. I get 555.45040 feet. Okay. Now, furthermore, so basically, we learned the theory from example 1. This is the theory. Okay, that's already application of the theory, but the one that closer to our real life problem is example 2. Now, then how do we answer questions like in example 2? You kind of sketch the situation first, and from that situation try to get the right triangle at which you can apply what we did in example 1. Okay, next, area of a triangle. Area of a triangle. If we have a triangle, then the area, you know what, I don't like this triangle. Any random triangle actually. Suppose I have a triangle. We say that if this is the base and this is the height, then the area of that triangle is equals to 1/2 base times height. Okay, now the thing is, what if we don't have the height? What if we don't have the height, but we have two sides and one included angle? Let's say I have, this is side A here, this is side B, and this is angle C. So if I have two sides and included angle, means that angle is exactly in between those two sides, then what will the area be? Now, notice that I can take out this triangle here. I can take this triangle out. Maybe I use this one. Let's stick. Okay, I will take this triangle out. This guy. Take this guy out. Okay, take that guy out. Now, this, then for that triangle, for that right triangle, this is B, this is angle C, and this is the height. Right? Now, what relates the height and angle C and side B?
Sine.
Sine.
Sine
So
theta.
sine C equals to the height over B. Right? In other words, we can say the height with base A. Okay, the height will be B times sine C. Now that's what I will put back in there. Now my area of the triangle becomes 1/2 times, what's the base?
C. The base is A.
The base is A, that's right. The base is A. How about the height?
The height is B sine C.
B sine C. Now we get a new formula for the area of a triangle. Okay, that's the area of a triangle. Area of a triangle with two sides and included angle known. Okay, memorize this formula. Memorize this formula. suppose suppose I use this formula here into number 16. Number 16 on page, this is 6.3. Number 16 on page page 452. So I have a triangle whose two sides are 4 centimeter and 6 centimeter, and the included angle is 70 degrees. The question is, find the area. Find the area. So the area will be 1/2 times the product of two sides times the sine of the included angle. Okay, so this will be 12 sine 70 degrees, which then when I use my calculator, I get 11.27631 centimeters squared. Okay. Now, what happened if we have question like number 18? Ooh. Maybe we memorize a new formula. New formula. New formula. Area of an isosceles triangle. Isosceles triangle with known WLAC and vertex angle. So imagine if I have isosceles triangle, right? This is an isosceles triangle here. Isosceles means there are two legs that are congruent, okay? And this is what we call vertex angle. Okay, let's say this is R, then this is also R, and we call this theta. Okay, so the area of that triangle will be 1/2 times the product of two sides times the sine of the included angle. So that's 1/2 R squared sine theta. Now notice that this is basically the consequence of the general triangle formulas if you know one side, and if you know two sides and included angle, okay, where the A equals to B and the included angle is theta. Okay, now then, how do we use this to answer, for example, instead of answer question from a book, let's answer this question first. Do you know a hexagon?
Yes. Six
Okay.
sided.
Okay, so find the area of a hexagon whose radius is, let's say, 8 inches.
64 sine 60.
Okay, let's take a look first.
Oh, half of this.
Oh, hold on. We have a hexagon. Okay, I think I need to use the extra word regular hexagon. Regular hexagon means the length of each side is congruent. Each side is congruent. Okay, so this is a hexagon, and we say the radius is 8 inches. It refers to the distance from the center to any one of the vertices, any one of the vertex. Okay, so this is 8, this is 8. Now the question is, what is the theta though? Hexagon means 6 sides, right? Okay, so there are 6 triangles there. There will be 6 triangles there. Okay, and each angle will be what degree?
60.
How do you get that?
36 over 60.
360 divided by 6.
60 over 6. Sorry.
Okay, that will be 60 degrees. So then the area of that one triangle, that yellow triangle, will be 1/2 times r squared sine 60 degrees. Okay, which is 1/2 times 64 times radical 3 over 2. Because 60 degrees is a special angle, then you need to give me the exact value. Okay, now 64 divided by 4 is 16 radical 3. Okay, because the unit is inch, then this will be inch square. But that's the area for only one triangle though. So how about the area of a hexagon?
Just multiply that by 6.
That's right, that will be 6 times the area of that triangle. Okay, which is equal to 96 radical 3 square inch. Okay, now your turn. Your turn. The following is actually an interesting question. Find the area of a stop sign with radius, let's say 6 inches. Okay, now please don't ask me how many sides a stop sign have. You basically reveal that you never stop. Okay, I give you 3 or 4 minutes for this. So we are working on number 28, and then I sketch the graph. From that graph, I try to get the right triangles, and then I notice that the length of that antenna must be the length of the opposite of beta minus the length of opposite of alpha. Okay, now then let's see for A, what relates A and alpha and 30 degrees? I'm sorry, 30 yards. That's tangent alpha equals to A over 30. A equals to 30 tangent alpha. Okay, I suspect B will be the same, huh? Tangent beta will be B over 30 So B is 30 tangent beta. Therefore, the height of the antenna will be 30 tangent beta minus 30 tangent alpha. We can factor the 30. The answer in the top is okay, but I think answer in the second part is better. Okay. Now this one is harder because we deal with two triangles, but not super hard, not super hard. Okay, not super hard. Of course, you need to be patient in setting up though, in setting up the equation. Now, the hard one is as the following. This is a typical question I ask in my tests, my trigonometry test, okay, which can easily be solved if you know, for example, law of sine or law of cosine. But I don't teach you that yet, law of sine, law of cosine. I don't teach you that yet, okay? If I have time today, then I may develop that formula for you. Okay, law of cosine, but you know what, or law of sine, but not now, not now. Suppose in another example, I have the following situation, okay, AB, let's say equals to 30, okay, angle A, let's say is 41 degrees, and angle B is equals to, let's say, 53 degrees. I randomly pick numbers. And the question is, find the distance from C to base AB. Okay, pictorially, it looks like this. Say this is A, this is B, and this is C. The distance AB is 30. You can call it 30 miles, 30 inches, 30 centimeters, doesn't matter. Okay, and then angle A is 41 degrees, angle B is 53 degrees. The question is, find the distance C from AB, quote unquote, find the height of vertex C from side AB. Now notice that this 30 degrees actually covers the whole AB. Okay, so let me clarify that the length here is 30. Okay, and what we want is to find the height. We can solve this question easier using law of sine, but I prefer to hold it until later. You still need to know the basic. Okay, now how to do this problem? Let's assign some variable. Let's say this guy here is x. Let's say that's x. Then what will this be?
30 minus x.
That will be 30 minus x. Now, then you see that we actually now have two right triangles. A whatever C. Let me call that point D. Let me call this point D here. Okay, so this is A, this is C, this is D. This is 41 degrees. This is the height. This is x. Are you with me? and then another triangle. Another triangle. This is H. This is D. This is C. This is B. This is 30 minus X. And this is 53 degrees. Okay. Now notice that they have common H. Both has H. Okay. So on the left-hand side, later on the left-hand side, I will set the equation that satisfies this equation. That's tangent 41 degrees equals to H over X. So the H is equal to X tangent 41 degrees. How about the right-hand side, the right triangle on the right-hand side?
Line 53 equals H over 30 minus X.
Tangent 53 degrees equals to H over 30 minus X.
Oh,
Okay.
tangent.
Yeah, tangent. Okay. So H is equals to 30 minus X. Don't forget the parentheses. Tangent 53 degrees. Now notice that both of them equals to the height. Right? Now, so it means the expression on the left-hand side, X tangent 41 degrees is equal to 30 minus X tangent 53 degrees. Is it right? Now, I will solve for X here. After I'm done with X, then I will find the H, which is the main question. So X tangent 41 degrees equals to 30 tangent 53 degrees minus X tangent 53 degrees. I put the x's together. So X tangent 41 degrees minus plus X tangent 53 degrees equals to 30 tangent 53 degrees. Now we have done this routine before. Okay, I will factor the X, right? And then divide by whatever we have the group. X equals to 30 tangent 53 degrees over tangent 41 degrees plus tangent 53 degrees. Okay, now that's the exact answer. You can use your calculator. You can use your calculator to compute that. Okay, but let me just go forward. Notice that once we get the X, then the height will be X tangent 41 degrees. You can use either one of them, but we have this. I will use this one. I'll use this one. Okay, which is basically, what is my X? My X is 30 tangent 53 degrees over tangent 41 degrees plus tangent 53 degrees times tangent 41 degrees. Now let me ask you to compute the x and then the h. I give you 2 minutes to punch those numbers in. What's the x? Hmm?
41.
Nah.
Yeah.
No. Pay attention to your parentheses.
18.12629.
That's right. That's 18.12629. Okay. Now, again, the issue later on will have something to do with your order operations. Okay. Notice that the denominator has 2 terms. Okay. So when you type your calculator, you will type it this way. The calculator work will be for x, you will be type 30 tangent 53 degrees divided by, now this is crucial, parenthesis of tangent 41 degrees plus tangent 53 degrees, close parenthesis. You see what I mean? Okay, you need to use parentheses here. You need to use parentheses here. You need to use parentheses here. Because you are dividing by the sum. Without that parenthesis, you divide by tangent 41 first. Whatever the quotient, you add tangent 53. So I think that's the reason you get something more than 30. Something more than 31 instead. Okay, because you didn't use proper parentheses. Now, then whatever I get for that x, I multiply by tangent 41 degrees. I will now get here 15.75694. Okay. Let's see your suggested homework for this 6-3. Suggested homework for 6-3, that will be number 1 to number, I think number 7 is good enough. 1 to number 7. And then try number 13. That's an interesting question. Of course, 15 to number 25 to number 25. Okay. The main topic is really to set up the equation instead of just solving. Okay. You won't be able to solve if you don't set it up. So be patient in setting it up. Okay. Now that's for today.